In a previous video, I discussed how reservoirs fill, and I also went a little bit into why it is that they can take so long to empty. In that previous video, I ended with this slide where I was discussing the filling of Norfork Pool during the 2011 event. And you can see at the later part of April that you do get a rapid rise in pool elevation, and then it stays high for about a month and then begins to decrease back down to the top of conservation pool, which is the orange line. So basically it takes 2 weeks to fill, 4.5 weeks to empty. I also showed the inflow and outflow that was occurring at Norfork during this event. You can see that you do get a spike in inflow at the end of April, which you would expect to see a spike of inflow at the end of April if you're getting a rapid rise in pool elevation. You can also see that you do get some subsequent inflow that comes in, especially during the month of May, but you also get some small amounts of inflow that are coming in throughout the summer and fall. The red line that's appearing are the releases. So you can see that the releases tend to be pretty low, even during the large spike that occurred in late April, and then it picks up. Looks like we had a spill that occurs in the early part of May, and then you can see that you do get this kind of steady release that's occurring as you're moving water out of the flood pool at Norfork. I also discussed the downstream regulating stage, which is Newport, and you can see that you get above the regulating stage. So the red line is showing the higher allowable regulating stage if the reservoirs are relatively full. And the yellow line shows the base regulating stage. So you can see that once we get above regulating stage in the late part of April, the middle part of April, we actually stay above regulating stage until about mid-June. So again, here you see that you get this rise. So just to summarize this slide, you get this rise that occurs over a 2-week period. And it takes about 4.5 months to empty. That rise is caused by an increase in inflow. And then you can see that the outflow occurs over a 4.5-month period to empty the flood pool. You can also see that we have these intermediate steps in our regulating stage, and with this higher allowable regulating stage due to the reservoirs being full. But you can also see that we really are unable to access those because Newport stays so high that basically having this higher allowable regulating stage didn't really come into play during this event. And here you can see that you're above regulating stage all the way from basically the mid to late part of April all the way to about mid-June. So just to back up and go a little bit into detail about the basin itself, you'll hear me talk about the controlled areas. And what I mean are areas that are controlled by both Shoals and Norfork Dam. So here's Shoals Dam and here's Norfork Dam. And this is a basin map that was produced by watersheds.org. And it's helpful to give you this understanding of the White River Basin. The White River Basin does run through northern Arkansas and southern Missouri. So we have the Beaver Basin. By the way, on the main stem, you have Beaver, Table Rock, and Bull Shoals. And then Norfork Dam is on a tributary to the White River called the North Fork of the White River. So the basins that are controlled are Beaver, James, Bull Shoals, and Norfork. Now, you can see that Bull Shoals and Norfork Dam, that they both release into the White River, and then they make their way down the White River and eventually will contribute flow to Newport, which is our downstream regulating stage. And Newport occurs just downstream of the confluence with the White and the Black rivers. However, there is quite a bit of what I term as uncontrolled area. And when I say uncontrolled, I just mean that it's downstream of Bull Shoals Dam and Norfork Dam, meaning that it's outside of the control of those two dams. Most of this is uncontrolled. However, there is Clearwater Dam on the Black River, which will give a little bit of control, but when I use the term uncontrolled in this case, just means that not controlled by Bull Shoals and Norfork. So all of the basins that have a red star are outside of the control of Bull Shoals and Norfork, and that actually represents 55% of the area that contributes flow to Newport. So basically greater than half of the area that contributes flow to Newport is outside of the control of Bull Shoals and Norfork dams. So on this plot, we're looking at the blue that's showing up. This is the contribution of Bull Shoals and Norfork dam releases at Newport. And don't really have specific numbers that I wanted to show at this point. I wanted to give more of a visual demonstration or a visual graphic of the contribution of Bull Shoals and Norfork dams to the flow at Newport during the 2011 event. And you can see that during this first rise that occurs in the late part of April, early part of May, that we're able to capture a very large portion of the flow that's in those controlled areas, because most of the flow that's occurring at Newport, which is shown by the orange, is not being contributed by Bull Shoals and Norfork Dam. It's not until you start reaching the late part of May, early part of June, that you start to see a more significant contribution. And the reason for this, and you'll see this in a later slide, is that Bull Shoals Dam was spilling during this time. The other thing to notice is that as you progress through the summer and even into the fall, that you can see that this blue becomes a greater portion of the total that's at Newport. And that just means that the releases from Bull Shoals and Norfork Dam are contributing more to the total flow at Newport as those projects are being emptied. And you can see that's one of the areas of interest, but also it will show why it takes so long for those dams to empty. So I also wanted to show what's happening at Bull Shoals and Norfork with respect to the releases. The chart at the top is the chart that you've already seen. So we can look at the Bull Shoals releases. One thing to point out is that the scales are different on each one of these plots. The Y scales are different. So just keep that in mind as you're looking at this. But you can see that we did get quite a bit of an increase in release for Bull Shoals. And we can see that appear at Newport. We look at Norfork. See that the releases are relatively small until we get this increase in release that occurs in the early part of May. And again, the scales are different, but you can see that increase in release at Norfork showing up at Newport right here. Again, as I pointed out, we're continuing to gain space at Newport. And so we want to make up that space with releases from Bull Shoals and Norfork to make sure that we get them emptied. So one thing that I had noticed is that it appears that during the time when it looks like that we were getting more and more capacity at Newport, that Bull Shoals releases tended to be rising in general. And then Norfork tended to be flat for at least during the early periods. So maybe during, mid-July to maybe early September, it appeared to be flat, which tells me that the three-lake system of Beaver, Table Rock, and Bull Shoals was likely more full than Norfork during this time. So priority was given to Bull Shoals. So as we got more space at Newport, that space was given to Bull Shoals to try to balance that three-lake system with Norfork. So here's another way of looking at the data that might be helpful. What I did for this plot was I removed the Bull Shoals and Norfork releases from the Newport flow. So this blue line is just showing the contribution of flow at Newport from what we term the uncontrolled area, from that 55%. This orange line is the base regulating stage at Newport. And you can see that according to the base regulating stage, we actually do get capacity sometime in June. And then we actually do have the higher allowable regulating stage. And that depends on, I don't go into too much detail in these videos about that, but if the lakes are very full, we're allowed a higher regulating stage. But one of the things to point out here is that you get above the regulating stage, and this is just for the flow in the uncontrolled area. So we get above regulating stage in about mid to late April, just based on the uncontrolled flow. And the uncontrolled flow alone keeps us above regulating stage until the early part of June. So that gives part of the answer of why it takes so long to empty, because we're at about 5 or 6 weeks where just the uncontrolled area is keeping us above regulating stage without any releases from both Shoals and Norfork being taken into account. So I wanted to also show what happens at July 1st, August 1st, and September 1st, because even though we reach regulating stage, that 55% is still having an impact on how quickly we can release water from the reservoirs. So if we look at July 1st, 53% of the capacity at Newport is taken up by the area below both Shoals and Norfork. So right now, that's over half of the capacity that's still being used by this uncontrolled area. By the time we get to August 1st, we still have 34% of that being taken up. And by the time we get to September 1st, we still have 26% of that. So you can see that this uncontrolled area, it's quite large, and it still plays an impact. So even on September 1st, when we're still trying to get these reservoirs empty from what had occurred in the late part of April, we're still being impacted by the uncontrolled area that's below both Shoals and Norfork. So hopefully that gives you a little bit more insight into why it can take so long for reservoirs to empty. I thank you for watching this video, and if you found it helpful, please subscribe to the channel. Thanks.